Hello my dear friends, in this video we'll learn the procedure how to solve the truss element and what are the characteristics of the truss element to define before going to solve the problem. So it is very much important. First we need to define the node numbers and the element name we need to give before going to solve the problem in a given type. We'll start giving the node numbering and element names with respect to the coordinate condition. So we have to bring all the nodal data and the coordinate data should be in a positive value. All the data what we are collecting from the given problem should be in a positive manner, means we need to define a given problem and taking a beginning point should be a very carefully, a very important. How we need to define the beginning point of the truss element to solve the problem we'll learn first. See here, a first task of the given problem is how we have to define a given problem. All data should be in positive coordinates. For a truss to bring the all values of nodal coordinate data in positive value, that is, see here I have given you one example, one of this example, another example we'll get the complete idea. So you can see here a truss will get start is this one, right? So this is the one of the truss element which will give in your external examination, and axis will not represented in a blue color what I have represented in a figure. In a figure I have represented along x-axis and y-axis in a blue color and red color. What the red color you are seeing, only that much you will get in your external examination along with some parameters value. We need to solve the given problem in a positive manner, means we need to represent the axis. The axis we are selecting is very much important to bring the all nodal coordinate data in a positive way. Likewise, see here, so when I'll draw a axis from here, for example, if I'll start from this node, assume there is no node numbering, so I need to start giving the node numbering. If I'll start from here, means the axis you will give here x and y axis is this one, and this is also a y axis. So this node will I'll say as node number 1, and this node I'll say as a node number 2, this node I'll say as a node number 3, this node I'll say as a node number 4. This node number 1 and 2 will come in a positive axis along x-axis, and rest of this these two node number 3 and 4 will comes in the negative axis. The nodal data whatever you take in a tabular column or in a solution, all the values should becomes in a negative manner. So these are the coordinates should be in a positive, all these values should be in a positive to solve the problem in a convenient manner, to bring that easiest procedure. So what we'll do, we'll not go with this method. So always after getting this problem we'll start from this point. Okay, so I'll make a x-axis with this point along this direction, and as well as I'll draw a y-axis from this point of a view. Now you can easily understand this. I'll say as a node number 1, this I'll say as a node number 1, and this I'll say as a node number 2, this I'll say as a node number 3, this I'll say as a node number 4. When I'll take the value of this x along x-axis along y-axis with respect to this node number 1, we have that x1 y1 we have 0 comma 0. Likewise after that along x-axis if I'll take this node number 2 value, what the value we have, that is also a positive value we'll get, and then this value, third nodal data value is also comes in a positive value. All the values along x-axis and along y-axis whatever it may be if I'll take. Similarly when I'll take at node number 4, it is also comes in the same manner. All the values what we are considering or preferring in a given coordinate, all the nodes will comes in a positive axis along x-axis and y-axis. All the values of the nodes are positive values, so that indicates there is no confusion. We will take that nodal data to solve the problem in a truss element. So all the nodal value comes in a positive axis. So likewise I'll take a next truss element. We have this another truss element. This is a one another truss element will give you to solve the problem. So here how we can identify which is the first node I need to take. So which is the first node you have to take means you have to draw a axis from here like this. From this particular node, lowest node, x-axis will move, and highest node from this left hand side, y-axis will takes. So that means all the values will comes in a positive manner like we have here. You can see, you can check out, origin will be here 0, 0. Node number 1 I have given for this, 2 and 3. Always the node number I am giving in a counterclockwise direction. So that means the direction of a node we are giving in a counterclockwise direction. In the same manner we are giving the element name. The element number 1 is lies between a node number 1 and 2, and element number 2 is lies between node number 2 and 3. Right? Similarly we have here node number 1 and 2, element number 1 is lies between these two nodes, starts from node number 1 and ends at node number 2. Similarly element number 2 is starts from node number 2 and ends at node number 3. And then the next element number 3 is very much important. So where it will get start from node number 3 and ends at node number 1. So how? So we are giving the names counterclockwise direction. Element number 3 will get start from node number 3 and ends at node number 1. It is very much important. And then similarly the next element number 4 will get start from node number 3 and ends at node number 4. It's start from node number 3 and ends at node number 4. It is a continuous from counterclockwise direction. We can easily understand, but only the main thing is this particular element number 3 for a 4 bar truss element. So this is the 2 bar truss element, 4 bar truss element we have. Similarly we have here a 2 bar truss element, this one, the element which is like this. So how we are giving that axis name from this direction, axis, x-axis and y-axis. Just you represent the axis. How we are representing the axis to give the nodal coordinate data is very much important. The origin you find out it correctly, then you can easily give the node number 1, 2 and 3, element number 1 and element number 2. Similarly we have next 3 bar truss element is this one. We have element number 1, element number 2 and element number 3. So how it has been represented along x and y axis. Origin, start the problem solving from this point and start the problem solving from this point. You can easily identify after drawing that axis. So what you will say, similarly we have a 3 bar truss element. You can start from this point. It is a node number 1, node number 2 and node number 3. This is an origin along the x-axis, etc. we have. You can solve any method, but this method may helps to reduce the confusion of sign convention in a nodal coordinate data. Only for a purpose of nodal coordinate data, while we'll solve the problem in a first step, it will remove the confusion in a sign convention, right? So now we'll go with the solving how to solve the problem procedure completely, step by step. After positioning the node and elements in a axis to bring all the data in a positive coordinate, to remove the confusion of writing a nodal data, will solve the problem the step by step. The procedure will learn. That is, a first step of finite element method is a finite element model. I have considered a truss which transmits a only axial force, that is, it is a combination of more than one bar or a link elements which has a relative displacements due to axial loads. I have considered a truss element has a two nodes, node number 1 and 2. Each node has a 2 degrees of freedom. Along x-axis, q1 displacement at node number 1, q2 displacement at node number 1. Q3 and Q4 is a displacement at node number 2. 2 degrees of freedom at each node we have chosen as per your curriculum. But we can solve on a 3 degrees of freedom also in a truss element. After getting a FE model, usually we have gone for a elemental stiffness matrix. In this particular truss problem, we have to write a nodal data and as well as elemental connectivity data. To get this idea, I have taken an example of a 4 bar truss element. By using this, first I'll define what is mean by a nodal coordinate data. Then we'll go for elemental connectivity data. These are the two tabular column is very much important to get a elemental stiffness matrix for a given truss element. We will get a area of cross section and x modulus from a given statement or given problem. Effective length of the element we need to find, direction cosines of each element we need to find. For this requirement of elemental stiffness matrix, these two tabular columns are required. Now we got why this required and how we need to get this. First we'll get the idea. A nodal coordinate data. We have got an idea by positioning all the nodal and elemental values in a positive coordinates. Y means to get this tabular column value should be in a positive coordinate. That procedure is helps to write the all xy values in a positive manner. Now we'll get the idea. So what are the datas we are representing along x and y axis with respect to a node number 1, 2, 3, 4 and so on is said to be as a nodal coordinate data in a space. Now I'll consider an example. A 4 bar truss element we have. I'll represent in a axis x and y axis. I will say this is said to be as a node number 1, node number 2, node number 3 and node number 4 based on our assumptions. Then I will check out which is an origin. This is the node number 1 is an origin and it has given a length of this truss element along x axis is 100 mm, along y axis 200 mm. Now I need to take each and every nodal data, then I need to tabulate that in a tabular column. So node number 1 I have tabulated, x value and y value for a node number 1 I will take. Node number 1 where it is lies at an origin, x value is 0, y value is 0. And then similarly we have a node number 2 along x and y axis. It is away from the origin along x axis 100 mm and along y axis is 0. X axis 100, y axis is 0. X axis 100 I have taken, y axis is 0 for node number 2. Similarly node number 3 along x axis it is away 100 mm, along y axis 200 mm it has been defined. X value is 100 and y value of the node number 3 is 200. And next to node number 4, it has a shift with respect to the origin along y direction 200 mm, along x axis is equals to 0. X value is 0 and y value is 200 for node number 3. We are giving the x position value of node number 1 and y value of node number 1 is said to be as a nodal coordinate data for a node number 1. X value and y value we are giving for node number 2 with respect to the position of a given problem. That values is said to be as a nodal coordinate data for node number 2. Likewise, how many numbers of nodes are there? That much numbers of node numbering and rows will get increased with respect to the x and y value. We got the idea how we are giving the nodal coordinate data. After getting that nodal coordinate data, next data we need to collect from a given problem. As I have discussed, stiffness matrix is required length of the element, direction cosines. Without this we cannot be get a elemental stiffness matrix in a truss element as we know, and I have explained clearly the direction cosine in a derivation of elemental stiffness matrix for a truss element. Here again I will take an example of a 4 bar truss element to write a elemental data. First elemental data required element. How many elements are there? We have 4 elements. This is element number 1, element number 2, element number 3 and element number 4. So 4 elements are there in a truss. We will say this is a 4 bar truss element. Okay, then initial node value for element number 1, element number 2, element number 3. Likewise we need to take final node value. After that we need to identify and we need to find out the length of the element. How we will find out the length of the element? With respect to the initial node and final node, x final and x initial will take from the nodal coordinate data. From the nodal coordinate data we'll get the final value and initial value as we have here. Similarly direction cosine is also depends upon this nodal coordinate data. If you'll mistake taking the nodal coordinate data, this complete tabular column will goes wrong. If this tabular column will goes wrong, a elemental stiffness matrix will goes wrong. If the elemental stiffness matrix will goes wrong, the whole problem will get wrong. So this all the nodal coordinate data and elemental coordinate data you have to take care while you will take a data from the given problem. How many numbers of elements I have considered? I have considered a 4 numbers of element. That means 4 rows I need to draw in a tabular column. Element number 1, where it will get start from node number 1, initial node value 1, final node value 2. Similarly, element number 2, what is the initial node value? Initial node value 2, final node value 3. Element number 3 is this one. So element number 3 will get start from where? At node number 3 and ends at node number 1. So 3 1. And element number 4 will get start from node initial node is a 3, final node is 4. So likewise we need to write a elemental data. After getting that initial node and final node, we need to find out the elemental length for element number 1. So for element number 1, we can easily identify the element number 1 is having a parallel to this length. Having a parallel to this length means the elemental length is equals to 100 mm. And then similarly element number 2 is a parallel to this 200 mm. So then it is start from node number 2 and ends at node number 3, 200 mm. Now the element number 3, very important here, it has been inclined. It is not parallel to this 200 and it is not parallel to this 100 mm. How we need to find? Now we require this equation. So this equation, distance equation, is helps to find out the elemental length, where it will get start from node number 3 and ends at node number 1. Here I'll take separately now. I'll take element number 3, start from node number 3 and ends at node number 1, L3, which is equals to, what is the final node value? X final, from where it will get start from node number 3. X1 is equals to 100, Y1 is equals to 200. Why? It is initial value for a node number 3. Why? Element number 3 will get start from node number 3. X1 value is equals to 100 and ends where? Node number 1. X2 value is equals to 0, Y2 value is equals to 0, final value. X final is equals to 0, Y final is equals to 0. We have this one. And X initial is equals to 100, Y initial is equals to 200. By using these values, we will get some result. So that resultant value is called as an elemental length value. We'll find by using this distance equation. Similarly, in element number 4 will start from node number 3 and ends at node number 4, which is parallel to this 100 mm. I'll take a 100. Likewise, we'll find the elemental data with respect to the length of the element. Similarly, we need to find out a direction cosine. A direction cosine for element number 1. For element number 1, how we'll find our direction cosine? Final node value, X final is equals to 100 and Y final is equals to 0. X initial is equals to 0, Y initial is equals to 0. See here, element will get start from node number 1 and ends at node number 2. Initial values are 0 0, final values are 100 0. Direction cosine L is equals to X final minus X initial divided by LE. X final is how much? 100. X initial means 0. 100 minus 0 is 100. This value, total value, divided by LE. LE is nothing but what? 100 we have. So that is equals to 1. L is equals to 1 for element number 1. And similarly, direction cosine M, we need to find what is that Y value, Y final value. Y final is equals to 0 here. So we have Y final is equals to 0 and Y initial is equals to 0. Y initial is equals to 0. 0 minus 0 is 0 divided by 100. Again will give it is M is equals to 0 for element number 1. Likewise, we need to find out for each and every element direction cosine. Here we need to tabulate. We have these equations. Again, this equation in an elaboration form. We'll not use now this nodal coordinate tabular column. We'll use this now a elemental connectivity data here to get this elemental stiffness matrix is very much important. You can see here we want a length of the element for element number 1, element number 2, element number 3. We need to find separately, as we have found in a bars problem. We have a area of cross section and Young's modulus from the given data of a problem. Direction cosine for element number 1 we have found this one, and m we have found. We need to substitute all those values in this stiffness matrix. Why we have did this all the exercise here? In step number 1 we have did the exercise in a step number 1 here to get this tabular column to find the elemental stiffness matrix. If we don't know how to get this elemental coordinate data and a nodal coordinate data, we are not able to get a elemental stiffness matrix in a truss element. Then we know that 2 cross 2 matrix in a bars problem, each node has a 1 degrees of freedom, but each node has a 2 degrees of freedom. We have a 2 nodes, 2 cross 2 is equals to 4. Then we'll have a 4 cross 4 matrix. This 4 cross 4 matrix is representing here based on the nodes. Node number 1 has along x-axis q1 displacement. This is the first row, first column value is equals to q1, and second row, second column is equals to q2. This is a node number 1. And what we have, this third row and third column we have, this is an a q3 at node number 2 along x-axis. This q4, fourth row and fourth column, that is a q4, depends upon the node number 2. Each node has a 2 degrees of freedom. That is the reason elemental stiffness matrix we have a 4 cross 4 matrix. In a bar element we have only a 2 cross 2 matrix. Each node has a 1 degrees of freedom. After that we know that how many numbers of elements are there, that much numbers of matrix will get elemental stiffness matrix. Bring that as a global stiffness matrix, k1 k2 plus kn. Global displacement vector. So I have considered a 2 bar truss element to define that global displacement vector. We have a element number 1 and element number 2. Element number 1 q1 and q2, q3 and q4. Elemental displacement vector q1, q2, q3, q4 for element number 1, and element number 2 q3, q4, and then q5, q6. Global displacement vector will comes in continuously here, q1, q2, q3, q4 at node number 2, q5, q6 at node number 3. This is called as a global force vector. And then similarly as a force where we have of f1 displacement q1, f2 q2, f3 q3, f4 q4, f5 q5, f6 q6, where we have a node where we have displacement same direction, we have the force. At each node 2 degrees of freedom means 2 forces are there. Along x-axis force is there, along y-axis force is there. That means 3 nodes, 6 displacements, 6 numbers of forces. We have here example f1, f2, f3, f4, f5, f6 for this particular example. We have n numbers of nodes, n numbers of degrees of freedom, n numbers of forces are there, f1, f2, f3, fn. That is a global force vector. After getting this all characteristics of a given element, global stiffness matrix, global displacement vector, global force vector, next step is fourth step, equilibrium equation, k into qf, as similar to the previous problem. Then we need to apply the boundary condition. Then we need to find the displacement. After finding the displacement, stresses in each element we need to find. Here the stress equation sigma is equals to E divided by L minus m L m qi plus 1, qi plus 2, qi plus 3. This equation is only satisfied for a continuous element. If there is having a discontinuous nodal element, like in a 4 bar truss element, this element number 3 start from node number 3 and ends at node number 1, this will not satisfied. You can see here I have given for this element and element number 1, element number 2 and element number 4, it is satisfied this equation, but this element number 3, this is not satisfied. That will be start from 5 6 1 2. You can see here 5 6 1 2 element number 3 displacement vector we have here, start from 5 and 6 and ends at node number 1 and 2. You can see here, if I'll give qi, I is equals to 1. For example, I'll take this element number 1. Okay, q1, q2, q3, q4 continuously we have I is equals to 1. If I'll take, it will start q1, qi plus 1, q2, qi plus 2, q3, qi plus 3, q4. Correct. Similarly, when I'll take element number 2, start from 3, I is equals to 3. If I'll take, what will happens to this? Q3, and then q4, and then this one 3 plus 2 5, and then q6 3 plus 3. So we have 3 4 5 6 continuously. If we'll have, we can easily get. But here we have, he started from 5, I is equals to 5, and then if I'll give I is equals to 5 means this will be 5 and this will be 6, then it will be 7. But here it will get start from 1 2, right? So for this particular element, this equation is not satisfied. Carefully you have to take, okay, directly. So that is the reason I have taken here. You can see now, you can easily get understand for element number 1. Okay, q1, q2, q3, q4, q1, q2, q3, q4 we have taken. This remains same, and then this will remain same for element number 2. This element number 2, q3, q2 will start from q3, q4, q5, q6, q5, q6. Similarly, we'll have this is will remain same, but it has been inclined. Start from 5 6 and ends to 1. Okay, 5 6 1 2. Here it is continuous, but it is discontinuous. Very important. So that is the reason that equation is not satisfied. Then this one, start from 5 6 7 8, 5 6 7 8. Now you got the idea, I think. This is generalized equation just I have taken. And then how to find out the reaction force? We have this idea, R is equals to kq minus f. Similar thing we have. There is nothing changed. After all getting the procedure, a main task to define the forces. We have got how to solve the problem, but while I have gone for the evaluation, if the inclined force is given, they are not able to solve the problem in an external examination. I have realized while I have the valuation of so many script in FEM. See here, if they have given the inclined forces, this is a 3 bar truss element where the force is exerting at node number 3, right? Maybe this one is fixed, clear. Force has been inclined at a 45 degree. How will resolve? This is the resultant force. Just I have taken here 45 degree. Resolve that along horizontally as well as vertically, along horizontal axis and vertical axis. At this node, you have two forces based on the given force direction. Along x-axis, F cos 45, along y-axis vertically downwards minus F sin 45. Just you write down the value of the force is given, and sin 45 multiplied, one force you will get. This one force, another force you will get. Likewise here, another one direction. The force has been inclined. If the inclined forces are given, resolve that inclined forces into a x and y axis by using a trigonometric function, and then same position draw it the given truss element, represent that x and y axis forces. You can easily identify how the forces is exerting on a given problem with respect to the given inclination force has converted in terms of a horizontal and vertical force, resolved forces, and solve the problem. These are the conditions what you have, what you will get in your external examination. You get it, the idea. So this idea you get it carefully. Clear? Resolve that forces and make it the two forces and along y-axis and along x direction. You know the trigonometric function, no need to tell in depth. After getting this procedure and idea, we can easily solve the problem on a truss element. Thank you for listening my lecture. In next video, I'll solve the problems on a truss.